Hi learners, welcome back to Dilk. In this video, we are going to discuss about carbylamine reactions, which is also known as isocyanide test. So here what is happening? Primary amines on reaction with chloroform and ethanolic potassium hydroxide, which on heating it will produce isocyanide. This is isocyanide, so don't be confused with nitriles and isocyanide. What is nitriles? Nitriles are RCN. So the alkyl groups attached to the carbon atom. So we can draw like R, C, triple bond N. So these are nitriles or cyanides. This is isocyanide or carbylamine. Okay, it is Rn triple bond C. The nitrogen atom is attached to the alkyl group. So this is isocyanide or carbylamine. Isocyanate, not isocyanate. What are isocyanate? Isocyanates are Rn double bond C double bond O. These are isocyanate. Okay. So in carbylamine reaction or isocyanate test, the product formed is an isocyanate which has a foul smell. So only primary amines can undergo this reaction because we need two hydrogen atom attached to the nitrogen for these reactions to happen. So only primary amines can undergo this reaction. Secondary and tertiary amines cannot undergo this reaction. So this reaction we can use as a test for primary amines. So that this test is known as isocyanide test. And if the amine on treating with chloroform and ethanolic potassium hydroxide on heating, if it is producing the foul smell is produced because of the presence of isocyanide. Isocyanide is formed only if the amine is a primary amine. So we can use this reaction as a test for primary amines. So what are the reagents? Chloroform and ethanolic potassium hydroxide on heating. Then product is isocyanide RNC, a foul smelling substance. And what is the specificity? Only primary amines, aliphatic and aromatic, both of aliphatic and aromatic amines gives this reaction. So why it's a test for primary amines? Secondary and tertiary amines do not give this reaction. The unmistakable foul odor of this isocyanide makes it a quick laboratory test for the presence of primary amine. And it is also known as isocyanide test because of the formation of isocyanide, that is carbylamine reaction. Now we can move to the mechanism of this reaction. There are totally 3 steps for this reaction. The first step is that formation of dichlorocarbene. Second is attack of the primary amine, and the third step is dehydrohalogenation. Totally there are 3 steps for this reaction. So firstly, what are the reagents of our reactions? We have chloroform and ethanolic KOH reacting with primary amines. The first reaction is happening between the chloroform and the ethanolic KOH. Then the product from this reaction is reacting with the amines. Okay, that is the first 2 steps. So we can look at this formation of dichlorocarbene. Strong bases such as potassium hydroxide removes the acidic hydrogen of chloroform. Then chlorate is lost. So what is happening in the chloroform? It is reacting with hydroxyl ion. So it is releasing the water molecule and CCl3 minus. This CCl3 minus, this compound is releasing chlorine ion Cl minus from this compound, and as a result of that it produces dichlorocarbene. Okay, this intermediate dichlorocarbene is a neutral but highly reactive because this carbon atom in the dichlorocarbene is highly electron deficient. So because of that it is a neutral but highly reactive species. Now for the first step is the formation of dichlorocarbene. Now what will happen? We know we have another reactant, that is primary amine. So primary amines there are lone pairs on the nitrogen atom which is nucleophile. Amines are Lewis bases, right? At the same time the dichlorocarbene, it is electron deficient species. So the lone pair on nitrogen attacks the electron deficient carbene so that it will produce N substituted dichloromethyl amine. So what is the name of this compound? This is a nitrogen atom, there is a substitution, alkyl substitution. So N substituted dichloromethylamine. Okay. So first step is the formation of dichlorocarbene, then formation of N substituted dichloromethylamine due to attack of the primary amines with dichlorocarbene. Now the third step is that elimination reactions to make the isocyanide. There are 2 elimination reactions to form the isocyanide, that is known as double elimination, that is dehydrohalogenation. So means D means removal, Hydro means a water molecule. Halogen means halogen atom, X. So dehydrohalogenation means removal of hydrogen and halogen atom. So we can look at this reaction. The alcoholic KOH removes the HCl from the intermediate twice in succession so that it produces the corresponding product. We can look at the first, what is a product that we got after the attack of the primary amines, the N-substituted dichloromethylamine, right, RNH2CCl2. So the potassium hydroxide removes the HCl from the intermediate. So that what we will get for the first removal of HCl, we will get RNHCCl. Then there is again hydrogen atom and chlorine atom. So it can again remove hydrochloric acid. The potassium hydroxide can again remove an HCl. So from RNHCCl, it is again removing HCl. So from RNHCCl, it removes HCl. So we will get RNC. This is isocyanide, right? What is isocyanide? RN triple bond C. This is isocyanide. So we will get isocyanide. So this is our isocyanide product, right? So as a result of this reaction, the isocyanide carbylamine RNC is formed, which has a foul smelling product that conforms the primary amine. So the overall reaction is that amines reaction with chloroform and alcoholic KOH, which on heating it will produce isocyanate, and side products as KCl and water molecule. Now we can look why secondary and tertiary amines do not give this reaction, why it is specific to primary amines. Basically we can see that what is the difference between primary, secondary and tertiary amines. Primary amines has 2 hydrogen atom and 1 alkyl group attached to nitrogen of the primary amine, but in secondary there are 2 alkyl groups and only 1 hydrogen atom, and in tertiary there are 3 alkyl groups and no hydrogen atom. So forming an isocyanate RNC, it needs nitrogen to lose 2 of its substituent as HCl. We have seen the third step, dehydrohalogenation. 2 times HCl is removed. So we need 2 hydrogen atom attached to the amines, right? But in primary amine we know that there are 2 hydrogen atoms, so the reaction is possible. But in secondary amine there is only 1 hydrogen, and tertiary amine there is no hydrogen atom. So this dehydrohalogenation reaction will not happen. But we know this first step can happen, the formation of the dichlorocarbene, and as a result of this formation, attack of the primary amine. This can happen, right? Because the nitrogen has lone pairs and the dichlorocarbene, it has electron deficiency. So that we can say finally that step is possible. The lone pair can attack carbene. The lone pairs of nitrogen can attack on the carbene in primary and secondary and tertiary reactions. But in primary amine, the next is dehydrohalogenation. 2 times can happen, and as a result of that, it can form the carbylamine. So it is carbylamine test or isocyanide test is positive for primary amines. At the same time, for secondary and tertiary amines, the first 2 steps can happen, but the third step, the important step, dehydrohalogenation, cannot happen. So they are negative and do not give carbylamine test. So finally we can say 2 hydrogen atom to form the isocyanate. Secondary amines wants to react but lacks the second hydrogen, so no isocyanate test. And spot the trap. The lone pair attacks in all 3 amines. Failure is about the elimination, not attack of the amines. And what are the reagents we used? It is chloroform plus alcoholic KOH. Here the KOH used is alcoholic KOH. We should not use aqueous KOH. Aqueous KOH cannot undergo this reaction. So that is about the isocyanate test or carbylamine reactions.